Hello viewers, in this class we are going to be looking into shapes, geometry. Now in this particular case we have a problem we are going to be looking into, and the problem says in the figure above, PQST, which is PQ, S and T, is a parallelogram. This shape here, PQST, is a parallelogram, and TSR, which is TSR, is a straight line. You can see the straight line. If the area of angle QRS, this is the angle QRS, is 20 centimeters squared, which is if the angle of QRS is 20 centimeters squared, find the area of the trapezium PQRT. We have the trapezium PQRT, which is from this side down to this place straight to T up to P again, is what we call a trapezium, right? We call the shape trapezium. And you can take a good look at this shape we have here. You will understand that we have three different shapes here. First we have the parallelogram, which is this way. Then we have the triangle, which is this way, and then we have the trapezium, all of them put together, right? So before we can find the area of this trapezium, we need to understand what a trapezium is, right? Now a trapezium has four sides, which two of the sides are what? They are parallel to each other, right? Two of the sides are parallel to each other, which is this side and this side. They are parallel to each other. It means they cannot intercept, and the distance between both of them are the same. The distance from here to here is the same, and the distance from here to here is the same, right? So and then the other two sides are called the legs of a trapezium. This is a leg of the trapezium to the left, and this is the leg of the trapezium to the right. This is the base, this is the base. Trapezium has two bases. We have the base up and the base down, right? And those two bases are what? Parallel to each other. Now we have known what a trapezium is. We can now go forward to look for the area of the trapezium. And if you remember, you will recall that the area of a trapezium is given by A is equal to half A plus B H. Now the A I have here is for the base, and the B I have here is for this base, which is A is for the base up, then B is for the base down, right? Then this is the height of the trapezium. So we need to have this relation in mind for us to find the area of any trapezium given. So very quickly we can substitute in the values to get the area, but the parameters are not complete. We don't have the height yet. There is one way we can get the height of this trapezium so that we can be able to look for the area, because we cannot even we can't look for the area when we don't have the height. And remember, we were told that the area of this triangle here is 20 centimeters squared, right? So actually we can look for the height of this trapezium using this triangle, since the distance between the two parallel lines are equal. So the distance from here to here is the same with that from here to here. Now this is what we call the height. The distance, we call it the height, which is h. You can also take it from here, which is also height. You can take it from anywhere, right? You can take it from this side, you can take it from this side, but make sure you are not cutting below this point down. Right, so you are not cutting below the straight line and anything above the straight line. You are stopping at that point where the line cuts. Right, so from this point we can get the height of this trapezium so that we can be able to look for the area. So how do we do that? We know that the area of a triangle is half base times height. So we can use the area of a triangle which we were given and the base which we have as 8 centimeter to get the height of this trapezium. And if we do that, we have area of a triangle which is equal to half base times height. Right, our base will have as 8 centimeter in this case, so area, which is 20 centimeter squared, we have 20 is equal to half, our base is 8, then the height, so we have 20 is equal to 8 over 2h. Right, so this into this is 4. We have 20 is equal to what? 4h. Divide both sides by 4. We have that the height is equal to what? 5 centimeter. If you divide both sides by 4, 4 will cancel 4, 4 will be here, and this will be 5. So our height is 5 centimeter. Right, so we have gotten our height for this trapezium. Now we know that the distance from here to here are equal, and we can substitute the value of 10 for this side. Then there is one thing you need to understand. This line from this point to this point S, from T to S, is 10 centimeter. Right, and from P to Q is 10 centimeter as well. But from S to R, we have that is 8 centimeter. Right, so now the total length of this base is 18 centimeter, because you will add this one and this one to give you the total length of the base. Right, you are going to add the length from T to S and the length from S to R to give you the length of the base. So if we do that, we have then we have our 5 centimeter as the height. Then we can look for the area of the trapezium. Area of the trapezium is 1 over 2. Then the base for this is 10 centimeter plus the base for this one is 18. We added 10 and 8 to give us 18. Then our height, which is 5. Right, 10 and 18 gives us 28. Half into 28 times 5. Right, then if we divide, area will be equal to 28 over 2 times 5. 28 here will be what? 14. So area of the trapezium will be 14 times 5, and area will be equal to what? 70 centimeter squared. Right, so the area of this trapezium is 70 centimeter squared, which is the correct answer to this problem. This is the end of the class. Hope to see you next on our next class. Make sure you like, share and subscribe to the channel. See you on our next class. Bye.